In the last 3 videos that I posted, I solved these 3 integrals and each of them had a different trig substitution. So I want to explain why those trig substitutions worked. Where did they come from? So in the first one, we had a square root of a number plus x squared. We let our x equal a tan theta. Why? Why did we let our x equal a tan theta? Let's have a look at this triangle. So I'm going to draw a triangle and I'm going to label one of the sides as square root of 4 plus x squared, and then it's going to make sense, hopefully. So we're going to label this angle theta. Opposite it, we're going to put x. Now square root of 4 plus x squared, if we use the Pythagoras theorem, that has to be the hypotenuse, because the Pythagoras theorem says one leg squared plus another leg squared equals the hypotenuse squared. So for this to work, one of the legs is going to be 2, the other leg is x, and the hypotenuse is square root 4 plus x squared. Now you're going to take the 2 sides that don't have the square root. Those are the opposite and the adjacent, and you're going to make an equation using theta. So we have to use tan because we have the opposite and adjacent. So tan theta equals x over 2. Solve for your x by cross multiplying, you're going to get 2 tan theta. And that is exactly where we got x equals a tan theta from. So it's because of what they gave us in the square root, which ended up being the hypotenuse. Let's have a look at the second one. In the second one, we have square root of a number minus x squared. In this case, we let our x equal a sine theta. So again, we're going to draw a triangle to try to understand this. So right angle triangle, we're going to put theta in the same place. But now since we have square root of 4 minus x squared, which has to be one of the sides, it means that the hypotenuse has to be 2. And the other leg is going to be the square root of 4 minus x squared. And again, this is to do with Pythagoras. So if you solve the Pythagoras theorem, you're going to find the other leg to be root 4 minus x squared. So this is going to work. So once again, we're going to look at the 2 sides that do not have the square root. So those are the opposite and the hypotenuse. So we have to use sine theta. So sine theta equals x over 2, which means x equals 2 sine theta. And that's where x equals a sine theta came from. And let's have a look at the last type of trig substitution. So we have square root of x squared minus a number. And in this example, we let our x equal a secant theta. And again, we're going to draw a triangle and we're going to understand why it works with secant. So if we draw a triangle, put theta in the same place. Since we have x squared minus, means our hypotenuse is x this time. So if our hypotenuse is x, one of the legs has to be 2, and the other leg is going to be the square root of x squared minus 4. And again, this is because of the Pythagoras theorem. So which are the 2 sides that don't have the square root, the x and the 2? Let's make a equation for that. So we have the adjacent and the hypotenuse. So we're going to use cosine. Cosine theta equals 2 over x. And then we're going to solve for x, and we're going to get 2 over cosine. And we know 1 over cosine is just secant, so we're going to get x equals 2 secant theta. And that's where that equation came from, x equals a secant theta.